Hello everyone, welcome to yet another video series of measurement and instrumentation. So in last couple of videos we have seen about potentiometers. So module 3 consists of potentiometers and instrument transformers. So potentiometers are meant for measuring unknown EMFs, whereas instrument transformers are meant for measuring high high currents and high voltages. So basically instrument transformers are of two types. One is current transformers, the other one is potential transformers. In today's class we will see what are current transformers. So a current transformer is a type of transformer that is used to reduce or multiply an alternating current. So these current transformers are and potential transformers are used in power systems wherein which high voltages and high current are dealt. So you cannot directly measure those high current and high voltages. So for that you need to step down those current and voltages. For that purpose we are using current transformers. So it is not actually a full-fledged transformer which is used to for power transferring purpose. So these CTs and PTs in short are called as instrument transformers. So these are basically a measuring devices. So these CTs produces a current in its secondary which is proportional to the current in its primary. So these have some turns ratio. For example, the current value is of 1000 amps. These CTs will provide a corresponding secondary current which is of some 100 amps or 50 amps, which is easy for the operating personnel to measure those values. So current transformers along with voltage or potential transformers are instrument transformers. So there are basic types of current transformers based on their constructions. They are wound type current transformers and toroidal type current transformers, bar type current transformers. In wound type current transformers, the transformer's primary winding is physically connected in series with the conductor that carries the measured current flowing in the circuit. The magnitude of the secondary current is dependent on the turns ratio of the transformers. In toroidal current transformers, these do not contain a primary winding. In wound type transformers, these are basically like on ordinary transformers. We have primary winding, secondary winding, and the primary winding is wound on the conductors. The secondary windings will provide the corresponding step down secondary currents. Toroidal transformers are those which does not have a primary winding. Instead, the line that carries the current flowing the network is threaded through a window or a hole in the toroidal transformers. So the shape will be like a toroid. Some current transformers have split core which allows it to be opened, installed and closed without disconnect the circuit to which they are attached. So these transformers will not have a primary winding, whereas the conductor will itself act as a primary circuit. The third one is bar type current transformers. So bar type transformers are those that uses actual cable or bus bars of the main circuits as the primary winding, which is equivalent to a single turn. So the primary windings is the same conductors from which we are measuring the current. So the conductors will exactly act as the primary circuit like a single turns in the primary side. They are fully insulated from the high operating voltage of the system and are usually bolted to the current carrying type. So here we see the basic construction of a CT. So we have the main primary conductor and we have a hollow core along which the secondary winding is being conducted. So this is an example for bar type CT. So the primary current flows through the primary conductor, main conductor. So an EMF is induced in the secondary winding as per the number of turns. So the symbolic representation is given here, wherein which only a single winding is being present in the bar type construction, bar type transformers. So the primary winding is connected in series with a circuit carrying the current to be measured. When the current flows through the primary winding, it generates a magnetic field around the primary conductor. This magnetic field will induce a proportional current in the secondary winding according to Faraday's law of electromagnetic induction. The induced current in the secondary winding is proportional to the primary current but scaled down by the turns ratio of the CT, which means that it produces an induced current in the secondary according to the turns ratio. So a step down current value is being produced in the secondary. This scaled down current can be safely measured using instruments like ammeter, wattmeter or protective relays without exposing them to the high currents of the primary circuit. So CTs are crucial in power systems for various applications because without those current transformers we cannot able to measure the actual power carrying in each conductors, and they ensure accurate measurements of current while maintaining safety by isolating measuring instruments from the high voltage circuits. So we have provisions for measuring the step down current. So we have certain types of ammeters which measures a high range of currents, but for very high values we don't have accurate meters, so we need to step down those values. For that we use CTs and PTs. So CTs and PTs are instrument transformers, as well as they gives isolation from the primary circuit, which are the high power circuits, from to the measuring circuit. The uses of CTs are, they are used for current measurement and monitoring in power systems, and they are used for measure overcurrent and fault detections in electrical circuits. And energy metering, billing in utility applications are done using CTs. Ground fault detection can be done by using current transformers, and CTs are used for motor and generator protections also. And also in power quality analysis and monitoring purposes these CTs are used. The main advantage is that it measures high current easily and it has high electrical isolations. Yes, it separates the high power area from the measuring side, so it provides an isolation, and the construction is very simple, hence it is easy to maintain and install. And also the controlling devices, it used as controlling devices to provide protection to the circuits. The main drawbacks is that the large exciting currents produces more loss in the transformers, and hence the transformer efficiency becomes lesser. And also the exciting current in the transformer remains fairly constant. So during load or no load, these transformer currents are high, and the main purpose of this exciting current is to generate flux in the transformers. So more amount of power is being used for producing flux alone, so high power loss also is engaged in this current transformers. So with this we comes to the conclusion of the CTs. In the upcoming module we can see about the working of PT, potential transformers. Thank you for listening. Happy learning.